It is 65 million years ago. Unsuspecting dinosaurs are going about their day, but they have no idea that catastrophe is just around the corner. An asteroid the size of Manhattan is heading their way. As it strikes our planet with 20 kilometers per second, the skies are lit up. A huge fireball emerges from the present-day town of Chicxulub, Mexico. Everything in the area is wiped out and the asteroid leaves a crater the size of London. For the next few years, our beautiful planet is unrecognizable. The blue oceans and green lands are obscured as the entire planet is enveloped in dust. A nuclear winter emerges and 75% of all species do not survive. But right now, in the vastness of space, millions of asteroids continue their silent orbit. Some of these space rocks are on paths that could bring them dangerously close to Earth. Or even worse. Without intervention, the history of the dinosaurs could repeat itself, with cities or entire regions obliterated. And to prevent such a disaster from ever happening again, NASA and ESA have joined forces in a planetary defense mission. Their goal is to develop a system capable of altering an asteroid's path, so if one ever targets Earth, we'll be ready to deflect it. I was invited inside the clean room at the European Space Agency to get an up-close look at the Hera satellite, a crucial piece of technology for this mission, and to find out how it's going to help save our planet one day. And I have to say, it was definitely one of the coolest experiences of my life. You may have seen this video of when NASA smashed a spacecraft into an asteroid. This was not an accident, but part of NASA's Double Asteroid Redirection Test, or DART mission, where they tested the kinetic impactor method, a planetary defense technique where spacecrafts are kamikazed into asteroids to alter their course. NASA's ship was traveling at a speed of 6.1 kilometers per second when it struck Dimorphos, a small moonlet orbiting the larger asteroid Didymos. The impact created a huge plume of debris that stretched over 10,000 kilometers. This was captured by the Hubble Space Telescope and resulted in stunning photos. But the collision did not just yield pretty pictures. Measurements from Earth confirmed that they indeed managed to alter the course of Dimorphos. Its orbit around Didymos was slowed down by 34 minutes. And this marked the first time humanity had intentionally changed the course of a celestial body. The DART mission was a great success, but of course their spacecraft was lost in the process. Accurate data needs to be retrieved in order to turn this experiment into a well-understood technique that can be repeated if a killer asteroid is ever heading our way. And that is exactly what Hera is trying to achieve. But to understand why missions like these are crucial, it is important to underscore the reality of asteroid impacts. While they are not daily occurrences, asteroid impacts are far from rare. Most smaller asteroids burn up in our atmosphere due to the intense heat generated by air friction. However, if you look at the moon, you'll see a surface littered with craters. This isn't due to bad luck, but because the moon lacks an atmosphere to protect it, giving it its characteristic appearance. But our atmosphere doesn't provide complete protection. Larger asteroids can and do reach the Earth's surface, and when they do, the consequences can be devastating. In 2013, an asteroid the size of a school bus struck the Russian city Chelyabinsk. The shockwave damaged over 7,000 buildings and injured almost 1,500 people. To date, there are 190 known impact sites on Earth, each a good reminder of our planet's vulnerability to collisions from space. Asteroids that are less than 10 meters across, like this one, typically pose little threat as they usually completely burn up in Earth's atmosphere. Small asteroids of around 4 meters strike Earth around once per year and usually result in a bright flash, but no significant ground effects. An asteroid like this one is considered a city killer. These range from about 100 to 300 meters in diameter. Average asteroids in this range strike Earth roughly once every 20,000 years, and they would completely vanish an entire city. However, the most scary ones are planet killers. These are asteroids that exceed 1 kilometer in diameter. Such an impact occurs approximately once every 500,000 years and can produce a 10-kilometer crater. These cause global devastation and potentially lead to the collapse of civilization as we know it. Currently, space agencies all over the world are tracking 2,000 asteroids that fall into the category city killers or even larger. So to have a solid planetary defense strategy in place not only sounds cool, it might actually save our planet one day. And it is time to find out exactly how that is supposed to work. I arrived at the European Space Research and Technology Center, or ESTEC. Suited up in protective clothing and hairnets, we entered the clean room, a sterile environment where Hera was being prepared for its journey into space. As I stood there, just meters away from the satellite, the real magnitude of the mission hit me. But with only about 15 minutes available to spend inside the clean room, every second counted. But I did not want to miss out on the opportunity to conduct interviews with the team behind it. I had the chance to speak with Paolo Martino. With over 12 years at ESA, Paolo was a great person to talk to about the mission's goals.
So we've been able to impact an asteroid and to change its course. However, to be able to use it for planetary defense, there is a lot of science in the middle. We need to validate and further refine our models that will tell us how effective are those impacts. Because the first results show us that the deflection was better than expected. Yeah. Now we have to understand why, and we have to understand then if and when we can use this technique again in the future. The only way to fully understand this, it is to have a full characterization of the asteroid. Yeah. You have to understand what is made of, what is its structure, what is its mass, its size. You really need all the details so that you can fully understand what happened in the impact. And the only way to do this is to be there.
Paolo also told me that they are going to use CubeSats in this mission. These can be thought of as space drones because of their small size and maneuverability, and they will perform some of the riskiest measurements. The Juventus CubeSat carries the smallest radar instrument ever flown in space, and it is going to conduct the first radar sounding inside an asteroid ever. This is similar to a medical CT scan and will offer a detailed view of its internal structure. Juventus will also land on the surface of Dimorphos to measure its gravity, a task which has never been accomplished on an asteroid. The mission involves Hera chasing the asteroid, matching its velocity, and entering its orbit before launching Juventus. This CubeSat will then make a precise landing on Dimorphos while both are traveling at extraordinary speeds through space. It's like landing a bullet on another bullet. And this is all happening while being hundreds of millions kilometers away from Earth. It's really incredible. Its companion, the Milani CubeSat, is equipped with a hyperspectral imager that will analyze the sunlight reflected off Dimorphos to assess its mineral makeup. This detailed surface analysis will allow scientists to understand the asteroid's composition in great detail. By collecting all this information, Hera and its space drones will help scientists understand how much force is needed if we ever needed to change the course of a killer asteroid.
The plan is to have a category of mission which are more fast reconnaissance orbiters. So once we find something suspicious, we will be able to find a fast and agile spacecraft to investigate the asteroid from close by, see what it's made of, and see exactly where it's going. And at that point, we might decide that it is necessary to actively take action against that.
As my time inside the clean room was nearing its end, I had one final question for Paolo. Are we in danger?
So we are not in imminent danger now, but now is the time to prepare for the future, because the question is not if, but when. We know that in the future, asteroid will hit Earth. The scale the time scale is not as dramatic as you see in some movies.
Yeah.
The real planetary defense application case is always spanning over several years. You might see an asteroid that has an impact probability with Earth over 3 to 5 years, which is non-negligible, and you want to be 100% sure that nobody gets hurt. But this is one of the few natural disasters that can be actively prevented. So we are working on that.
Hera is currently undergoing final tests in Noordwijk and is scheduled to launch aboard a SpaceX Falcon 9 rocket this October. After launch, Hera will embark on a 2-year journey to reach its destination. As part of this journey, Hera will perform a close flyby of Mars and come within just 5 to 8,000 kilometers of its surface. This maneuver will boost Hera's speed and help set its course toward the Didymos system. The spacecraft is scheduled to rendezvous with Didymos in October 26, when it will be approximately 195 million kilometers away from Earth.
The whole scientific community also on the other side of the ocean is eagerly awaiting for Hera to be there and have the full characterization of what happened with the successful impact of DART.
Huge thanks to the European Space Agency for inviting me over. Let's hope that we don't have to use asteroid deflecting technology anytime soon, but it's inevitable that one day we will. And when that day comes, it is reassuring to know that we're going to have a system in place to take the necessary action. Standing next to a satellite that is part of such a colossal mission was definitely one of the coolest moments of my life, and I'm very grateful that I got to experience it. In any case, I really hope you enjoyed the video, and if you did, don't forget to like, subscribe and comment for the algo, and as always, I really hope to see you in the next one.